This video for quarter 3 assessment is about sequences. It's our Unit 11 practice. A mistake people tend to make is that they forget to check the equation in the calculator to make sure the table of values matches the original sequence you were given. Calculator may not tell you how to write the correct equation, but it will definitely tell you if the one you picked was incorrect. So please make sure to check your equation in the calculator. Okay, write a formula to find the nth term of the sequence below. So looking at this, I recognize that this is an arithmetic sequence because I am adding a -4 each time. So I can write my sequence as, let's see, a of n equals my first term, which is 11, my common difference, -4, times n minus 1. Remember, if you simplify this, you could also get something that will represent this sequence as well. If I simplify this, I'm going to get 11 minus 4n plus 4, which is 15 minus 4n, which you should recognize as my slope y-intercept form. Okay, this is my explicit formula. Both of them technically are explicit formulas. This is the one we usually see for arithmetic, but this one also is correctly representing this. So let me use my calculator to make sure. I'm going to type in the equation 11 minus 4 times x minus 1. And I'm also going to put in this other one, 15 minus 4n. And let's see what we get. Second graph, table of values. And I go to where x is 1. And I notice the first value is 11, just like it is here. My second value is 7, just like it's here, and so on. So this is telling you that those two equations do correctly represent this. Don't be in a hurry to pick something that comes close to it. It's got to be exactly the same. All right, which sequence has a common difference of 5? So I look at this, and this definitely has 5, but since it's going down, this is a -5. So that does not work. This one is going up, but I am multiplying by 5 each time. Now, if this said a common ratio of 5, that would be my choice. But a common difference means I am adding 5 each time, so that does not work. This 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. That definitely looks like it's going to work. Let's make sure by being able to not accept this final answer. So this 7 plus 5 is 12. That looks like it's going to be the same thing. But then 12 plus 4 is 16. That does not work. Common difference means I am adding 5 every single time. So C would be my correct answer. Now let's take a look at a recursive sequence, which often, does not always, but often includes more than one operation. And it is always referring to your previous term. So if I have f of n, then f of n minus 1 just means I need to put the value of the previous term. Okay, we already know f of 1 is -1. F sub 2, I'm going to take the value of the previous term, I'm going to multiply by -3, and then I'm going to add 1. So I'm going to multiply my previous term by -3 and add 1. And every time I'm going to get to the next term, I do that same pattern. I'm going to take the previous term, multiply by -3, and then add 1. And I needed to find the next 3 terms, which means second, third, and fourth term, and I will do the same pattern. Now all you do is just put the previous term value in here. So f sub 2 is negative 3 times the previous term, negative 1. Negative 3 times negative 1 is 3 plus 1 is 4. F sub 3 is negative 3 times the previous term. So I look at the previous term, which is 4. I put that in. Negative 3 times 4, negative 12 plus 1 is negative 11. And then finally, my fourth term, negative 3 times the previous term, negative 11. Multiply that and add 1, and I get 34. So those would be my next three terms. Okay, now let's take a look at a word problem. Sophia's practicing her foul shots. On the first day, she makes 2. On the next day, she makes 5. And on the third day, she makes 8. If she continues in this pattern, write the explicit formula to predict how many foul shots S of n that she will make on the nth day. So a helpful way to see this pattern is just to write those numbers in order. So we have 2, 5, 8, and they're saying it would continue in this pattern. First thing I'm going to do is ask myself, is this an arithmetic sequence? Well, 5 minus 2 is 3. 8 minus 5 is 3. So it definitely looks like I am adding 3 each time. And to write this formula, the explicit formula, I need to use the variables they gave us. So S of n is going to be the number of foul shots, and n is the number of days. So these are our foul shots. S of n would be the first one that I started with, 2, with the common difference of 3 times n minus 1. That's my explicit rule. So that is my formula. I should have written it here, so let me just write that again. And now you're asked, how many foul shots should she expect to make on the 13th day? So they either gave me S of n or they gave me n. 13th day, I look here, and n is the number of days, so they just told me n is 13. So S of 13 equals 2 plus 3 times 13 minus 1. You could do this mentally. 13 minus 1 is 12. 12 times 3 is 36, plus 2 is 38. Or you could grab your calculator, go to your display, and just type that in. 2 plus 3, parentheses, well, 13 minus 1 we know is 12, and that gives us 38. So on the 13th day, she would expect to make 38 foul shots. Okay, we have another word problem. Annie's practicing for a marathon. On the first day, she runs 100 yards. The next day, 200 yards, and the following day, 400 yards. So first day was 100, next was 200, next was 400, and so on if we're looking at a pattern. Using an explicit formula, how many yards should she expect to run on her 6th day? Okay, they're not giving me any particular variables to use. I'll look at this as arithmetic first. So 200 minus 100 is 100. 400 minus 200 is 200. So I'm not getting the same result when I subtract a previous term from this. Let's see about geometric sequence. 200 divided by 100 is 2. 400 divided by 200 is 2. So I do recognize that I'm going to be multiplying by 2 to get each term. So that's our geometric sequence. So that would mean that f of n is going to be my initial amount, 100, my first term, 100, times our common ratio, 2, to the n minus 1 power. This is my first term. Then I need to make sure the number 1 shows up there. How many yards should she expect to run on her 6th day? So I'm saying f sub 6 is 100 times 2 to the 6 minus 1 power. And I can put that right into my calculator. 100 times 2 to the, well, 6 minus 1 is 5. And she'd expect to run 3,200 yards. So now a marathon is approximately 44,000 yards, because a marathon is roughly 26 miles and there's 1,760 yards per mile. So approximately this. When should she first expect to run that amount? So I want you to pause the video and think about how to get the answer for this. Okay, remember with a geometric sequence, at this stage you can't solve algebraically for the missing exponent, which is what you were asked to do. When should she first expect to run that amount? We need to find the number of days. So the way that you solve this or get an answer is you need to write, I entered my equation in y equals, show the table of values, show your final answer in the middle, and why the number right above it wasn't big enough, the one after it was too big. So this is when she first would have run at least 44,000 yards. Obviously, a pace like this she couldn't expect to continue doing, but that still would be doable if she wanted to work at that pace to get to the 10th day at least. And then you would need to write on the 10th day. Right, so this has been an SOS video on sequences, Unit 11.